Hello students, today I will cover a syllabus on BSc 5th semester paper 1 real analysis, which is the syllabus of Karnataka University Dharwad, in which unit 1 Riemann integration. I am Dr. Krishna B. Chavareddy, Government First Grade College, Nargon. Today in this session I would like to solve some problems on box sums or Riemann sums. Let us see the first problem. F of x equal to x for all x belongs to closed interval 0, 1. And let P be the divisions. We have divisions like this. So then we have that partition over this 0, 1 interval. And now we can compute that is upper sum and lower sums there. Now let us divide this interval into subintervals, respectively I1, I2, I3, I3. And corresponding that length should be here delta 1, delta 2, delta 3. Since function is x, it is increasing in nature in this interval. So corresponding that, those I1, I2, I3 subintervals, we have that supremum and infimum respectively is capital M1, small m1, capital M2, small m2, capital M3, small m3. With the help of these supremums, so we can find the upper sums and lower sums by make use of the definitions of those. So then we have respectively, we got it, that is the 2 by 3 and 1 by 3 by substituting capital M1, M2, M3 and small m1, M2, M3 in the expression of UP of LP of that. And next we shall move to the next problem by taking the function is x square in the interval 0, 1 and divisions are here. Four divisions, 5 divisions there, so that we have that we'll get 4 sub intervals there, respectively that I1, I2, I3, I4, and for this we have a equal length, that is 1 by 3, and function is, since function is x square, definitely it is increasing in nature over this interval, and corresponding this I1, I2, I3 we can find that is M1, M2, M3, M4. Similarly, infimums like small m1, m2, m3, m4. With the help of these supremums and infimums, we can find that is the upper sums and lower sums respectively. These. And also similarly, we can follow the same procedure in this problem, third problem. We can find that is the lower sum and upper sum for this function is inverse function 1 by x square. By taking that is partition here 1, 2, 3, 4 in the interval 1 to 4. So we can have that another problem, that is f of t. Only notation is different, and instead of x square we have a 3 square of the interval -1 to 2 with the partition is given, and evaluation sets these are these supremum and infimums. And then we can compute the Riemann sums. The partition determines the sub-interval lengths, or make use of this partition, we can find that, in which maximum length is 0.9, that is now P is 0.9. And for the evaluation set E, the Riemann sum is S of F, comma P, comma E. This is what we have, that is the supremum and infimum. This is like, as looks like it is a delta, it is sub-interval length. So that finally we got the answer. And then we move to the next problem. Use the Riemann sum to approximate the area under the graph f of x and the interval, given interval 1, 2, 3, and divisions are given here, 5 divisions, and function is x cubed. So we divide this 1 to 3 into 5 subdivisions, and corresponding that length we can have there, equal length we have there, make use of that equal length. And also we can have this graph there, so that figure. So we have divisions we have given, so that each division we can find it that, so that we can find the corresponding Riemann sum is f of 1 delta x, f of 1.4 delta x, and 1.8 delta x, f of 2.2 delta x, f of 2.6. That because we have a 5 here, so by that we can have. So that finally we estimate this result is the area to be 15.12 square meters. And another problem, last problem, we have a discontinuity problem. So one is that is the function is 1 for every rational number and function is 0 for every irrational number. Now we can find that is the upper and lower sums for this interval for an arbitrary partition. Take an arbitrary partition of the interval 0, 1, and definitely we have between any 2 points in the subinterval there is a irrational number. Therefore, infimum over that subinterval must be 0. That is upper sum. Lower sum is 0. So definitely between any 2 points in that subinterval there is a rational number also, and corresponding that the upper supremum over that subinterval must be always 1. So that upper sum is always 1. So thus we have shown that for the Dirichlet function and for any partition P, we have that supremum and infimum respectively, that 1 and 0. These are the references we have followed in this session. Thank you.